In the world of digital electronics, information is represented as a series of ones and zeros, a language known as binary. These binary digits or bits form the foundation upon which complex systems are built. Within this realm, a counter serves as a fundamental building block, responsible for tracking occurrences of events. Imagine a digital tally system, meticulously incrementing or decrementing its count based on incoming signals. This, in essence, is the role of a counter. Counters are sequential logic circuits, meaning their output depends not only on the current input, but also on the sequence of past inputs. This history-dependent behavior allows counters to remember and act upon previous events. Whether it's the clock ticking on your wall, the traffic lights guiding vehicles, or the engine of your car managing fuel injection, counters play a pivotal role in ensuring these systems function as intended. Their ability to count events and keep track of sequences makes them indispensable in diverse applications. As we delve deeper into the world of counters, we'll uncover the intricate mechanisms that drive their operation and explore the myriad ways they shape our technological landscape. At the heart of every counter lies a fundamental electronic component known as a flip-flop. These devices act as memory cells, storing a single bit of information, either a 0 or a 1. A flip-flop toggles between these states based on input signals. Counters use multiple flip-flops to form a counting chain. Each flip-flop represents a digit in the counter's binary sequence. Clock signal pulses synchronize the flip-flops, advancing the counter's value. Counters can be binary, decimal, or gray code. Binary counters increment through a standard binary sequence. Decimal counters count from 0 to 9 before resetting. Gray code counters change one bit at a time, minimizing errors. The clock signal dictates when the counter increments. Controlling the clock frequency determines the counter's speed, allowing precise timing. Perhaps the most ubiquitous application of counters lies in the realm of timekeeping. From the humble wristwatch to the atomic clocks that govern global navigation systems, counters form the backbone of these time-measuring instruments. In a digital clock, a crystal oscillator generates a highly precise and stable frequency, typically at 32,768 Hz. This signal serves as the clock input for a counter circuit. The counter then divides this high-frequency signal down to a more manageable rate, such as 1 pulse per second. This precisely timed pulse then triggers other circuits responsible for updating the display of the clock. Each second, the counter increments, and the display reflects this change, providing us with a visual representation of the passage of time. The accuracy of the clock hinges on the stability of the crystal oscillator and the precision of the counter circuit. Any deviation in the frequency of the oscillator or errors in the counting sequence would result in an inaccurate time display. Stepping out into the urban landscape, we encounter another ubiquitous application of counters: traffic lights. These silent guardians of the intersection rely on counters to manage the flow of vehicles and pedestrians, ensuring safe and orderly movement. Traffic light controllers often employ counters to establish the timing intervals for each light phase. A central clock signal dictates the overall cycle length, while counters within the controller determine the duration of green, yellow, and red lights for each direction. For instance, a counter might be programmed to count a specific number of clock pulses, representing a predetermined number of seconds, to hold the green light in one direction. Once the counter reaches its designated value, it triggers a change in the light sequence, switching to yellow and then red. Sophisticated traffic light systems utilize sensors and communication networks to dynamically adjust timing intervals based on real-time traffic conditions. Counters play a crucial role in these adaptive systems, ensuring that the timing adjustments are implemented accurately and efficiently. Section 5. Orchestrating events and timing. Beyond the realm of clocks and traffic lights, counters find widespread use in countless applications where precise event sequencing and timing control are paramount. They act as the invisible orchestrators, ensuring that operations occur in the correct order and at the right time. Consider a simple vending machine. When you insert coins and make your selection, a network of counters springs into action. One counter keeps track of the total amount of money deposited, while others manage the dispensing of products and the return of any change. In more complex scenarios, such as industrial automation, counters play a crucial role in synchronizing the movements of robotic arms, controlling the timing of conveyor belts, and monitoring the output of production lines. They ensure that each step in the process occurs in the correct sequence and with the appropriate timing, maximizing efficiency and minimizing errors. The ability of counters to precisely control timing intervals makes them invaluable in applications ranging from medical devices to telecommunications equipment. They serve as the hidden clockwork, ensuring that complex systems operate with the accuracy and reliability we rely upon. Section 6. Precision under the hood. Counters in automotive engines. Under the hood of modern vehicles lies a sophisticated network of electronic control units, or ECUs, that manage every aspect of engine operation. Within these ECUs, counters play a critical role in optimizing performance, fuel efficiency, and emissions control. One crucial application is in the engine control unit, which manages fuel injection, ignition timing, and other vital parameters. Counters within the ECU precisely measure engine speed by counting the pulses generated by a crankshaft position sensor. This real-time speed information allows the ECU to adjust fuel injection timing and spark plug firing with pinpoint accuracy, maximizing power output while minimizing fuel consumption and harmful emissions. Another critical application is in the anti-lock braking system, or ABS. Counters in the ABS module monitor wheel speed by counting pulses from wheel speed sensors. When braking hard, if the system detects a wheel locking up and therefore about to skid, the counter data triggers the ABS to rapidly modulate brake pressure, preventing skidding and maintaining steering control. As automotive technology advances, the role of counters in engine management and safety systems continues to expand. From optimizing fuel efficiency to enabling advanced driver assistance systems, counters are essential components driving the evolution of the automotive industry. Section 7. The pulse of industry. Counters in automation. The rise of industrial automation has been nothing short of transformative, revolutionizing manufacturing processes and increasing productivity to unprecedented levels. At the heart of this automation revolution lie counters, serving as the pulse of countless industrial processes. In robotics, counters are essential for controlling the precise movements of robotic arms. By counting pulses from encoders, which measure motor rotations, counters enable robots to position their end effectors with sub-millimeter accuracy. This precision is crucial for tasks such as welding, painting, and assembly, where even slight deviations can lead to costly errors. Counters also play a vital role in managing production lines, ensuring that products move smoothly through various stages of assembly and processing. They control the timing of conveyor belts, activate sensors to detect the presence of components, and track the number of units produced. As industries continue to embrace automation, the demand for sophisticated counter-based systems is only set to increase. From controlling the intricate dance of robots on factory floors to optimizing the flow of goods through global supply chains, counters are the unsung heroes driving efficiency and productivity in the modern industrial world. Section 8. Advancements on the horizon, high-speed and embedded counters. The field of counter technology is constantly evolving, driven by the relentless pursuit of higher speeds, increased functionality, and greater miniaturization. Researchers and engineers are pushing the boundaries of what's possible, leading to innovations in high-speed counters and embedded systems. High-speed counters are designed to operate at incredibly fast clock frequencies, enabling them to count events that occur in rapid succession. These counters find applications in fields such as high-speed data communication, particle physics experiments, and advanced imaging systems. Embedded counters, on the other hand, are integrated into larger integrated circuits, providing compact and efficient counting capabilities within a single chip. These counters are becoming increasingly prevalent in consumer electronics, automotive systems, and industrial control applications. Advancements in semiconductor technology, particularly in the development of new materials and fabrication techniques, are paving the way for even faster, smaller, and more power-efficient counters. These advancements will unlock new possibilities in fields ranging from telecommunications to medical devices, further solidifying the importance of counters in technological innovation. Section 9. The enduring relevance of counters. From the earliest days of digital electronics to the cutting edge of technological advancement, counters have played an indispensable role. Their ability to count events, measure time intervals, and control sequences makes them essential in countless applications. As technology evolves, the demand for adaptable counting solutions grows. AI and IoT present new challenges and opportunities for counter technology, requiring faster, smaller, and more intelligent solutions. Counters will be essential in enabling AI systems to process data and control processes. In the IoT, They will manage billions of interconnected devices, ensuring smooth operation of smart homes, cities, and industries. Counters are the keepers of order and precision in the digital world. As long as we rely on electronic systems, counters will remain essential, quietly shaping the technological landscape for generations to come.